Let's talk about software quality. What does it mean for something to be a quality item? What makes something of good quality versus not of good quality? Human readable. Okay, so in the case of software, human readability might be a thing that connotes quality, but more just quality in general. If I say this is a high quality item, what am I saying about the properties of that item? What makes it a high quality versus low quality item? Works well, right? I got the item because I'm trying to solve a problem. I want to use it for something. And if it does the thing that I need it to do, that makes it valuable. Business people call it fitness for use. And that means that there's a business value for both the customer and whoever's producing the item. If you're producing the software, the business value to you is people pay you to use it, or you somehow make money from it, let's say. And if you're the user, the product solves some problem that you have. And so it's reasonable to expect that quality assurance is the process by which you ensure that both sides of that relationship are getting maintained. What that means for software is, from the point of view of the customer, it solves whatever problem they have. From the point of view of the developers, it's relatively easy, well, easy in scare quotes, because software is just difficult. But the developer can debug it, can enhance it, essentially can respond to the customer's demands to make it even more valuable, right? So that's what software quality is, which means when you think about what does the software quality or software QA department do, or in a well-run modern software company, what should it do? What it used to be is you'd say, oh, we finished the code, and now we've thrown it over the wall to QA. QA does the testing. That is not how modern software companies are run. Or if you're at a modern software company that is run that way, you should run away screaming. Because what the QA department's job is to actually make sure that the processes and tools in the company are optimized to support those goals. If you're a developer at Google, but there's this famous anecdote where, anybody ever read the book Code Complete? Code Complete? I'll put up the programmer's bookshelf of books that everybody should have to be inspired by. But for a long time, there was this very famous sort of anecdote that at Microsoft, the ratio of software testers to software developers was basically 1-to-1. That for every person writing code, there was a person sort of paired with them to do testing. And a few years ago, we asked Google about this, and they were like, oh, I don't know, there's maybe one software QA engineer for every like 10 or 20 software developers. And should we be horrified? No, because the software developers are doing their own testing. The software QA engineers are in charge of the tools, processes, measurements, basically making it possible to do testing better, right? So testing is a first-class thing at Google and at most companies that take software engineering seriously. So this is, I think, maybe a different view of software QA, certainly a different view than there was sort of 20 years ago. I'm not sure what view most of you have had about this, but as a developer, you are responsible for your own testing. There are processes and tools in place that will sort of give you a handle on how well you're doing it. What form of testing do you do? There's really two different things that we want to know when we're building software, and we call them verification and validation. Basically, it's did you build the thing right? Did you build the right thing? So did you build the thing right means we have an understanding of what the thing is supposed to do. Does the thing you built actually do that? Does it behave that way? Versus did you build the right thing means are you sure that, in fact, we are in agreement about what the thing is supposed to do? Have you really understood what the customer's requirements were? Have you agreed on the specific features that will make those requirements, fulfill the requirements for the customer? And both of these can be tested in two different ways. We can do testing, which means we stimulate the software in various ways. We observe what it does. We conclude whether it's doing the right thing. And we can also use formal methods, which we won't really cover much in this class, but essentially formal methods are an attempt to formally prove certain things about the behavior of a piece of software, proving that it can or can't do enter a certain set of states. But even if we're focused on testing, exhaustive testing is infeasible. And when we talk about test coverage in a few weeks, it'll start to become clear why 100% testing, even if it were feasible, wouldn't actually be a guarantee that there were no bugs. So we do the best we can, and essentially we divide and conquer. We have different kinds of tests that are used in different phases of software development and that are testing different kinds of things. Some of these you may have had access or exposure to in prior programming courses. Coverage, we're going to talk about it in great detail in a few weeks, but essentially it is a way of asking how much of the functionality of my software is being exercised by all of the tests that I have against it. And as we're going to see, that is actually remarkably slippery to pin down because it depends very heavily on how you define the behaviors. But very roughly, here's the kinds of testing that we're going to use. Unit testing, probably a lot of you have done this at some level. This is where you're basically calling a single method, function, procedure, call it what you want, and you're verifying that under various inputs it does what was expected. It doesn't throw an exception. You get the right answer back. Above that is module or functional test, where you have some behavior that you want to test that relies on multiple different units. So it could be that it calls multiple different functions. It might call functions in different classes, but it requires sort of different pieces of the code base to work together to do something. And what you're checking is whether the behavior as a whole does the right thing. At a level above that is an integration test. You've got sort of major subsystems within your application, and there's assumptions about how those subsystems communicate. There are tests that would exercise whether the units are making the right assumptions, whether when they have to cooperate on a task, they're doing so in a correct manner. And finally, above that, there's whole system tests, also called acceptance tests. These have a couple of different purposes. One of them is to test the whole thing. So this is kind of the moral equivalent of you've just coded a new feature in a web-facing app. You actually log in as a test user, and you manually step through the things it's supposed to do. Because you're also testing, in that case, does the feature behave the way the customer said? Right? The way that we're going to do our feature planning is essentially show the customer pretend lo-fi mock-ups of the feature, and once we get to agreement on that, that actually becomes the basis for writing an automated test that does what the customer would do if they were stepping through the mock-up. So we're going to be using all 4 levels of these with a couple of different testing tools. I'm going to go out on a limb and say you're going to learn to love testing. I hope that you'll learn to love it and be happy, but you'll learn to love it, whichever way.